So what do you think? Crawl ordering. Is breadth first better, for example? Or is depth first better? Or should you do something that's more content driven? You should fetch pages that are somehow more interesting content first. And if it was to be content driven, what metric would you use? Well, to answer these questions, we can back up and we say, what are our goals for crawling the web? Well, one of the goals is to find good pages soon. Because after all, we may not finish the crawl before we have to start looking for new things again. So we want to get good pages, pages that are going to basically be in people's searches. We want to visit those soon. We want to visit them frequently. And then the other goal, of course, is politeness. So one heuristic might be to find pages that have a high page rank and prioritize those, right? And we could do that based on the knowledge of PageRank from previous crawls. So we could say, okay, we know PageRanks from all our previous crawls. Now we can look at the links that are on our frontier and prioritize them by their old PageRank. And in fact, research says that breadth first search will actually find high PageRank pages pretty quickly, because high PageRank pages are basically easy to find. There's lots of paths into them. Research also shows, therefore, that random prioritization of the search frontier also finds high PageRank pages quickly. Basically, you're going to run into the high PageRank pages if you do random search of the web. There are other ideas to do approximate PageRank online, for instance, if the contents of the web links are changing quickly. But basically, random or breadth first are both decent schemes to run into high PageRank pages pretty quickly. More generally, if you really want to get this right, I'm sorry, but you have to be at one of the search engines to know how this is best done. It really is part of their secret sauce for making sure that your queries are relevant and on fresh versions of the web. So it's hard to recreate this experience without a big cluster, without a lot of network, and without a good corpus of queries that people have asked in the past, so that you can determine what relevant really means to users as they click through on search results. Okay? But hopefully you got a sense of some of the issues through this discussion. Now, to scale up a crawler, to parallelize it, you might want to do a few things. Basically, you're going to partition the frontier of the crawler, that set of pages that are to be visited next, in a scheme that's similar to parallel join algorithms we learned in this class. Or if you're familiar with MapReduce, it's similar to MapReduce. But we're going to need to do a little bit of load balancing to get this to be reasonable. You might want to partition, for instance, by domain name, the prefix of the URL. Or you might partition by the entire URL. And one of the things to consider here, and you wouldn't have thought of this probably until you built your first search engine, is that DNS lookup can be a substantial bottleneck for nodes. You know, DNS lookup is the lookup you do on the internet when you map a computer name, like www.cs.berkeley.edu, to its current IP address on the web, which might be some 4 numbers like the one you see here. And so to make this go faster, you're going to likely maintain a local DNS cache at every node in your crawler. And that means you probably want to partition based on the domain name, so that a given crawler that's already cached a URL gets all the subsequent fetches for that URL. Okay? So the load balancing here has some peculiarities based on things like DNS lookup. Now, to learn more about web crawlers, actually there's quite a nice Wikipedia page on web crawlers, and I encourage you to read it. The focus of that page is mostly on academic papers, which is a bit unfortunate. It'd be lovely to know what's going on behind the doors at the big search companies. But the truth is, a lot of the original web crawlers came out of universities. The original web crawler came out of work that was done at the University of Wisconsin. The Ink2Me web crawler and web search engine, which was at its time the largest search engine on the net in the late 90s, came out of research at Berkeley. And then, of course, Google came out of research at Stanford. And so because a lot of this stuff came out of universities, let's hope that some of that academic research actually is relevant, even though it's been polished, obviously, at the companies. Now, bulk loading a web index is the next step. How do we take our crawled pages and load them into a web search index? Well, we learned how to bulk load B trees. We sort and then we bulk load the B tree, right? And that's nice. But of course, here we have to sort the entire web crawl, which is really big. And so we're going to have to do a parallel sort. And then we'd like to partition the corpus based on doc ID and build partitioned indexes. Okay? So this need to do parallel sorting with partitioning inspired Google to build their MapReduce infrastructure. And when we learn about MapReduce in a couple of lectures, keep in mind that it was originally developed as a generalization of code they had for building and loading their web index from their crawl.